So much to learn in this day. Well, you've already been introduced to negative exponents, so now we're going to do more things with them. Now, when you were introduced to negative exponents the first time, well, that's what an introduction is, you were doing whole numbers, and so you put the 1 underneath the whole number and flipped it. This time you have fractions. It's no different. You flip the fraction. So 2 over 5 to the negative 3. You apply the negative, and remember, it gets used up and thrown away. So then you have 5 over 2 to the third power. And then you apply the exponent. Now the exponent gets applied to the numerator and denominator. In fact, I'm going to write that down. To numerator and denominator. It'll work. And then the next step, I show you how it is. 5 over 2 to the third power is 5 over 2 times 5 over 2 times 5 over 2. That's 125 over 8. 5 to the third power, it's kind of like 5 to the third over 2 to the third. Well, it is like that, not kind of, it just is. It's messy and I don't like it. 5 to the third power is 125. 2 to the third power is 8. So that's what we do. That's how you apply the negative exponent when you have a positive fraction as the base. Remember, the base is the thing that it holds up the exponent. So now let's try this one. We're going to try 3 over 4 squared. That's like saying 3 over 4 times 3 over 4, or 3 squared over 4 squared. Either way you go, it's 9 over 16. It's doing the same thing. All right, 4 to the negative third. 1 over 4 to the third. Because remember, the negative is a tool. 1 over 64. Should have been something over 4. Oh well. We never changed the sign of the base. We just flipped it. And as I have highlighted, the negative sign does not affect the sign of the base. The negative sign in an exponent is a tool. Okay, we're going to apply the rules you already learned with negative exponents. The rules do not change. I'm going to write this up here. Rules do not change. 2 exclamation marks. So you learned how to use the product rule to solve expressions. X to the third power times x to the fourth is x to the 3 plus 4, which is x to the 7. Well, you do the same thing with negatives, negative exponents. You don't apply them yet. First, you do the product rule. 3 plus negative 2 is positive 1. So you have to remember how to add negative numbers. Okay? So 3 plus 2 plus negative 2 is the same as 3 minus 2. And that's how we get 1. Alrighty, let's do this with a base of 2. 2 to the negative 5 times 2 to the 7 means product rule. Add the exponents. So you have negative 5 plus 7 equals positive 2. 2 to the second power, which is 4. This isn't a complicated rule, but you have to remember how to add negative numbers. You've got to get really good at that. All right, you try. Stop, try it, and then see what you get. Y to the negative 2 plus negative 3, y to the negative 5 equals 1 over y5. Oh, that's sneaky, because you've got to apply all the rules. And that's why that one's there. The product rule applies. -2 plus -3 is -5. But you cannot leave it there. As I've got highlighted or bolded, all exponents in the answer must be positive. That doesn't mean change them to positive. It means do the math to make them positive. So just because if I've got y -5, I don't say, oh, it has to be positive, so y to the 5th power. No, I do the math. Let's do the next one. Well, you already did the next one. 3, oops, going to be hard to do in a highlight. 3 to the 2 plus -2 is 3 to the 2 minus 2 is 3 to the 0 is 1. Haha, sneaky. Multiple rules. We do it all the time. And that, by the way, is not a Z. It's a very messy equal sign. Alrighty. Sometimes you do get a negative exponent, as we had up here. So you've got to apply it. You are going to be, towards the end of this unit, like around now, you're going to have problems with multiple rules that get applied. You just do them step by step. All right, let's go to the next page. We did the quotient rule with negative exponents. Now we're going to do the product rule. Ignore this, I forgot to delete it. The quotient rule says, remember, when you divide bases that are the same, you subtract the exponents. Will you do the same thing if you have a negative exponent in the bottom or the top? Doesn't matter. So x to the 4 divided by x to the -2 is x to the 4 minus -2. Remember, when you minus a negative, you can connect them and make it plus. Is 4 plus 2, which is x to the 6th. So let's do this one. X to the -5 minus 2 is x to the -7. Then you apply it. So sometimes you're going to have multiple rules. We just did that with the product rule and negative exponents. We're going to do it with the quotient rule and negative exponents. All right, let's give this a shot. X to the 3 minus 5 equals x to the -2. I cannot leave this with the negative exponent, so I have to apply it. 1 over x squared, x to the 2nd power. Okay, let's try this one. 2 to the -3 minus -1 is 2 to the -3 plus 1 is 2 to the -2, which is 1 over 2 to the 2nd power, equals 1 over 4. Lots of steps, but that's because I always show the steps. Okay? Don't force the numbers to go where you think they should. Just do the math and they'll take you. And remember, when you subtract a negative, that means add. And as I said on the notes, you will sometimes have to apply more than one rule. This math is not difficult, but it is very detail-oriented. You have to pay close attention to what you're doing. Don't try to go too fast. All right, last page. The power of a power rule. So you've learned everything with positive exponents. Now you're going to learn the rest of the rules with negative exponents. All right, same concepts, nothing changes. So the power rule says when an exponent is raised to another exponent, you multiply them. So it doesn't change if it's a negative exponent. You still multiply them, but then you apply the negative. So we're going to try it with integers. 3 squared raised to the -3rd is 3 raised to the 2 times -3, which is 3 to the -6, which is 1 over 3 to the 6th, which is 1 over 729. So now let's try this one. Y to the negative 3 raised to the negative 4. Y to the negative 3 times negative 4. I'll write it. I'll write it clearer. I don't like the way that wrote. Make this better. Because there are a couple different ways to do it, and I'm just going to teach you one. Y to the negative 3 times negative 4. It's clearer that way. Equals y to the 12th. Oh, look, there's nothing I have to do. That's kind of cool. That was easy. Now there's a longer way. I'll show it to you. There is a longer way. It's still mathematically correct. Let's do it in blue. Y to the negative 3 becomes 1 over y3. And I'm still raising it to the negative 4. That means it becomes y3 to the 4 because I flipped it again. It's mathematically correct. I find it longer, but if that one works the way works for your brain better, do it that way. It's what works for you guys. So 5 squared to the negative 2. Well, let's just see. We can do this again 2 ways. 5 to the 2 times negative 2 equals 5 to the negative 4 equals 1 over 5 to the 4th equals, ooh, and I forgot that one. Hold on. I should remember that. Equals 625. Whoops. Oh. Here we go. 1 over 625. Now again, you can do it the other way. 5 squared is 25. You can say 25 to the negative 2, which is 1 over 25 squared, which is 1 over 625. Again, whichever way works for you, whichever works better for your brain. Okay, you have now learned, sorry about that, but you've now learned all the rules with positive exponents, and you've learned all the rules with negative exponents. The rules are the same, but with negative exponents, you just have that one more step to do.